gives off more heat than it absorbs.
Yeah, because it has all this currents. For example, there's these moons going through Jupiter's field. It's got this huge magnetic field, and you've got stuff like Io that's sort of this sulfur conductor. So you have a conductor moving through the magnetic field, you create current. So there's this stream of electrons going through Io and into Jupiter and back around. Like several trillion amperes of current flowing, and between the tide and the current stuff, that's why Io has all those volcanoes. It's a place that has all those volcanoes erupting. Right? So it's got really, really dynamic systems. Lots of intense radiation. So there's that probe called Juno, which is diving very close to the Jupiter and back out again. It was built to be very radiation hardened because it's just intense radiation near Jupiter, and it's surviving. It's kind of we're getting really close pictures of Jupiter going around there. But yes, Jupiter's a pretty intense. If you think about the solar system, and you take the sun out of it, minus the sun, Jupiter is about 88% of the mass of the solar system. It's just that one planet.
It's amazing. And did you ever figure out that red spot?
Yeah, excuse me, it was 83%. The red spot is a storm that's been on there that we know Galileo had drawings of it.
Right. It's like, why is it? I mean, it's like a perpetual storm.
But it's winding down. It seems like it's not. For example, as a childhood, it was much more red than it is now. So we think it's kind of quieting down. We don't know how long it's been there.
Well, it's been for hundreds of years.
But the storms just keep going. There's no rocks for it to run into. There's no continent of North America for it.
It's like one of the gas giants, right?
Yeah.
Just floating around.
Really intense. So yeah, Jupiter's 83% and Saturn is about 12% of the mass, and the rest is just full Earth and all the things.
I remember reading somewhere where you put Saturn in a big bowl of water, it would float.
Yeah, because it has mass. It's density is less than that of water.
Yeah.
So it's kind of where Jupiter's kind of pretty solid core. Saturn's kind of fluffy. Saturn's about if Jupiter's about 11 Earths diameters across, Saturn is something like 8 or 9. So Saturn's big, but not as big as Jupiter. But it's light and fluffy, whereas Jupiter's got this really intense metallic core inside. It's got hydrogens compressed to such a density that it turns into metal. And so it's got all these really weird electric currents going through there. So it's all this kind of Jupiter would have been if Jupiter about 70 times more massive, it would have been a star.
Yeah.
So it didn't quite. So
it could have. It almost became a star.
But it's off by a factor of 70. So I kind of missed it. But it sucked up a lot of material. In fact, the asteroid belt.
Yeah, I was going to ask you about the asteroid belt. Any theories about what that is from?
What we know now is that there's not enough material there to form a planet. Okay. The really heavy stuff sunk to the center of the sun, so Mercury's really metallic. Earth has got rock and metal and metallics. Mars is kind of light rock. Well, the planet that would have formed an asteroid belt was even lighter, but Jupiter is sitting right next to it. So the gravity just
ripped it,
pulled off, siphoned all the stuff, and ripped off all the material. So there wasn't enough material in the asteroid belt zone to form a planet. So Sirius is a nice round object, right? For it's a dwarf planet, but there's not enough material. They thought maybe that it was a planet that was broken up, but now we know that basically there's not enough material. So Mars is quite light compared with Earth, and it's kind of small, and also Jupiter ripped off its material. So Mars doesn't have water on the surface because it lost its atmosphere. It doesn't have enough gravity.
Okay.
So the oxygen that was there in normal temperatures just keeps it in space because the temperature allows it. So Mars would need to have a lot more gravity to hold its oxygen down there. So Jupiter kind of ripped off Mars as well.
Jupiter's like this.
Sucked up.
I know, it sucks up everything. It's a little greedy.
And it pulled up a little bit of Saturn too, I think. But it's got a nice circular stable orbit, so it kind of anchors the rest of the planets around it, so they don't get too wobbly.
I remember this thing called the Jupiter effect back in the 80s.
Oh yeah.
All the planets lined up and nothing happened.
Yeah. Sort of funny about that.
Yeah, I remember when I was a kid, I had that book. I was a couple more years. Okay,
So yeah, I can tell you like planets. That's why I was a planetary scientist, studied planets.
Yeah, that's why I saw that, so I was asking.
So there, but yes, we got a great stuff in there. Of course, I was really thrilled about the Pluto probe.
Yeah, the pictures are spectacular.
Oh, and amazing, and it showed us we didn't know about really cold planets. We thought cold planets were just going to be
It's just a big block of ice.
you know, but it actually it's got
Rocks.
rocks and geology, and it's got canyons and volcanoes and other weird things. And now we sort of say, well, you know, the surface of Pluto is probably about 37 degrees Kelvin, and the interior is about 44 degrees Kelvin. I think that's much more, but when you talk about that temperature, 44 is substantially hotter than 37. I mean, the ratio is there, even though it's only on degrees. So that ratio means you've got to read dynamic. Just like, for example, Earth having a mild temperature and a hot core, the same kind of thing is happening. But it's in the low temperature scale.
Okay, that should be interesting. Yeah.
And that's where all the stuff about the canyons and the cracks and the other things went on. It sort of taught us those small frozen things that way up dwarf planets are actually quite active, which surprised us because we didn't think.
And any progress as far as intelligent life on there?
We're looking. It's hard to detect planets, but there's probably about now, of the 3,600 planets we know, we've confirmed outside the solar system, something like about 6 or 7 are really nice.
Earth-like.
Yeah, they've got, they're not too hot, not too cold, sort of thing. Now the Earth-like planet that's around the star nearest to the sun, Proxima Centauri, we don't think has life because that sun is actually quite violent, has lots of violent bursts. So it might not be the best spot for it. But given just that we can only detect planets around the nearby neighborhood right now, we need better instruments. We'll get it there, but we know that stars outnumber planets. I mean, planets outnumber stars. So our galaxy has about 200 billion stars, and given the population around this, we think it has at least 1 trillion planets.
So, I mean, statistics.
So now you see when the odds, right?
Yeah, there's got to be something.
And given the odds that we saw around the neighborhood, it's just and that's only in a few thousand light years. The odds are that there's plenty of Earth-like stuff. Some are in early stages, late stages, middle stages. So just the odds would suggest that you'd probably a bad bet to say there's no life out there. That really did.
Right. There's always the dark side of the moon where you can't see. There's some people get hiding. Some aliens get hiding.
But we have orbits that go around that.
You just scan the dark side of the moon.
Yeah.
So.
And that's kind of funny because the dark side is actually a very different texture than the light side. In part because the moon presents one face to the Earth. Right. It used to be spinning just like the Earth was on its axis.
So it used to.
But the Earth slowed it down, and it stopped its spin. And the heavy chunk, the moon is not perfectly. It's not like a billiard ball. It's not perfectly uniform.
One side's heavy.
And that heavy spot is pointing down towards the Earth. So the face we see is the heavier side. But the moon also wobbles around. So for example, when the Earth is spinning and Asia is more massive, the moon kind of sees Asia go by and does a little bit of a twist. Yeah.
Okay.
So that's why you can see a little bit around the edges of something. The moon kind of wobbles a bit. But
okay. So it's not fixed.
It moves about 10 degrees side to side at maximum.
Okay.
Depending upon the configuration there. But it was surprising that people said the moon's alien has no atmosphere, no magnetic field, it's lighter than the Earth, must have been captured. But when the Apollo 11 rocks came back, they were Earth-like.
I want to know if this is his normal pre-op discussion.
No. Because, I mean, we have time. That's why it's
Yeah.
like.
Yeah,
And I've always been. I saw that you're into astrophysics. I gotta ask you these questions. It's always as a little kid, I've always been fascinated with astronomy.
So was I. Because my brother and I would see out in our farm outside between Hayward and Pleasant. Like to see about outside and look at the stars.
Yeah, I mean, we have our own telescope and we're looking up too. And
what other question do you have?
No, I'm sure I'm gonna have more. But they also said, like, for example, when one of the space missions, Apollo 11 or 12, maybe 12, when they said they dropped they jettisoned the lunar lander back down into the moon, and it caused an impact on the moon. They said the moon pinged the ring that was ringing for like over an hour. And they said, does the normal rock-like structures ring like that? And they said, but they recorded it. It was just reverberated for like over an hour. So there's something very
But the Earth is relatively solid, so when you bang something on a bell, it's going to
but it banged on the moon.
Yes, and so the seismograph that Paul Levin left are really sensitive, so it takes a while for those shock waves to dampen. But we get the same thing when the seismograph we detected, rocking the moon at a crater, you hear it.
But it reverberates for a long time.
Yeah, because there's not really anything to.
But is that normal for?
There's nothing to really dampen it, right?
There's no water.
There's no water and there's no atmosphere.
And no magma. There's nothing to absorb the.
There's no liquid squishy stuff.
So even if it's a rock-like structure, it's not unusual to expect some pinging for an hour or so.
Yeah.
Okay. Because they're saying, it could be a metallic structure. I don't know. You see,
But it doesn't
it's
have to
funny,
be
I
The
see it.
simplest thing is that it's probably the right one.
But it doesn't have the density for lots of metals in it, because all the metals, the dense metals stuck to the center of our planet. And
So it seems very unlikely that the moon is an artificially created structure.
it seems pretty, because they would have had to haul lots of earth up there.
Yeah, or just saying, yeah. it's
Who
like-
would have noticed that?
Yeah.
Yeah.
It would have been missing from,
Or that maybe the moon was created and brought into Earth orbit.
And that's what we thought was the case.
It's kind of like a giant Death Star. How they
But
build it,
that's why it was so important for the amount of rocks and analyze them.
Yeah,
Earth,
so
like all the radioactive isotopes of the same age.
They're all kind of lined up.
And all the things like the oxygen 16 oxygen 18 ratios, the nitrogen 14 15 ratios, the carbon ratios, the uranium thorium ratios are all Earth-like.
Really, it's interesting.
And in fact, it's hard to find rocks from the moon on Earth because they look so Earth-like. Even though because they could be a volcano melting them. So one reason we go down to Antarctica is when the stuff lands in the middle of that ice, it's not Earth contaminated. So we find an Earth-like rock in the middle of stuff.
Okay.
There's no swallows dropping rocks around.
When you see a rock on top of 2 miles of ice, it's probably not from around here.
Interesting.
And we get to remove it because they don't allow mining in Antarctica because they're not supposed to mine and take stuff. But if we can prove it's a foreign import, then it's like garbage and we can decontaminate it.
Oh, I see.
That's the bureaucracy. So.
Oh, okay. But it's all nations kind of have to agree.
Yeah, and so and you down there you have to get other people's help, right? So in order for people to cooperate, you have to agree to.
Agree on things, yeah.
And when you're down there, you just care where you're from, you just help people. In fact, it's kind of a thing because there's in the continent, it's about 2,000 kilometers from the edge of the center. There in the summer, the population might be like 1,300 people. Winter times around 150, 200. So when someone in your area and you find, there's somebody guy, he's 50 kilometers away, let's go and see him. It's like you're just right next door.
Yeah. You travel by snowmobiles
or snowcats or airplanes. When we do the airplanes, we use DC-3s. We fly in a DC-3,
Okay.
unpressurized, aircraft that works really well down in the cold.
So you have runways.
Well, there's only a couple of places you can run, and then from there you can take snowcats or snowmobiles.
Helicopters and.
Because also the big thing is that we gotta have the fuel. So when we go from the edge to the center, we have to build our own gas stations. So we come down a big cargo plane like the Lucian from tip of South America on the ice. We bring all the jet fuel, and then we start. The DC-3 starts without any passengers, takes and puts a load into the spot, comes back, and go back and forth, built a fuel there, and then you can fly there and make the next. Because you have to make your own gas stations.
Oh, interesting.
Right? There's no gas trucks coming along.
That's right. You don't have like a Chevron station to fill up with it.
You have to do your own service. So we had a on our snowcat kind of fell into a part of a crevasse and got stuck, and you have to dig it out because no one's gonna.
You can't call
Yeah, I was gonna say, we don't control AAA, right?
I did call AAA to say, I just want to do this. We're stuck and.
Just because you had an Iridium phone and you could call
Yeah.
AAA, so you did.
And AAA don't
I know you come as we were down here, and I had a AAA member, and she took my number and said, "Well,
So funny.
we'll be there in about 2 to 3 months. So
That's funny.
are you safe, da da da?"
That's right. Are you off the side of the road? Are you in a safe place?
I said, "Could you tow us to South America?"
That's funny. Oh, that's neat. Is the air very dry there?
Oh, yeah, it's very dry, about 5% humidity. So that's another thing
The
that.
skin gets really dry.
But you also can't expose yourself to the air because you're under the ozone hole.
Oh, that's right.
So in your high altitude,
All the UV.
your high altitude, ozone hole, and then this ice mirror. So you have to be, no skin exposure. Also, you have to have dark glasses and goggles and a face mask because you only have the damage to your eyes. And even inside of a tent, the tents we have are solar heated. And one of the things they do is they take the UV, the material sets allows the UV to come in and be absorbed and re-rated as heat.
Okay.
So you have to have inside your sunblock on and dark glasses on inside your
Even
tent.
inside your tent.
Because you won't, because again, the UV is just extraordinarily strong. And there's very little ozone at the top,
Right.
above there. So
Huh. So you just put a lot, you have to wear sunscreen.
SB 100 all the time, everywhere where you need to go. And that's sort of precaution, but it's the altitude is probably the biggest thing.
Because you're about what, so you said 14,000.
Well, the barometric pressure is typically like that, 14 to 15,000 feet, and because the gear you have on in the cold is just fine. He's down to about -60. But it's the altitude that can be a problem. Some people get altitude sickness, and unlike Everest, where they can take them down the mountain, you're in the middle of this continent.
So you just really no way to go down.
Nowhere to go down, and it may be weather tells you whether or not you can fly or not. So you might be sick, and they say, well, we can't get out here for 2 weeks. So
When you say -60, is that like during the winter or like
summer,
during the or your summer, right?
yeah,
When the sun's up.
yeah,
So even with the sun up, it's still that cold.
yeah. You get to go. So the highs could be about -30 or 40. Those are tolerable. The -60 is going to get a little bit.
So -30 even with the sun.
Yeah. The -60 with the sun, and then the winter times go from about -70 to about -90 Celsius.
Wow.
So that's where, at that stage, you want to be in one of those basic bubbles, because you can't get, because at -79 is one particular dry ice. Like, imagine air as cold as dry ice. You can't bring that in your lungs because you would just probably do
So you have to
nothing.
breathe oxygen.
Or you have to go. So even at around -40 below, you have a mask you put on, and your breath exhales, warms it. So when you pull it back, it is nice.
Huh. So it never really gets warm down like that.
No, it hasn't really melted in about 2 years.
So the only time I guess down at the coast is probably a little
Yes,
warmer.
because at the water edge where the penguins are,
Right.
you see penguins in water. It's near the freezing temperature.
Freezing, so
So it's relatively
considered
warm.
warm.
Yeah.
But when you're up at the high plains, it's
Because if it wasn't warm, the water would be frozen. You have more Antarctica.
right.
Antarctica is the extent where the warmth of the Southern Ocean meets the continent. So the base area is sort of that spot where you either have rock or ice resting on rock or ice permanently attached, like the shells, to stuff. That's there. So
if you see penguins, it's warm enough.
yes, the penguins are on that. So the penguins we typically see are on the tip of South America. When we leave there, we fly over the ocean, because the ocean has really bad waves, storms, and so forth. The storms that go around Antarctica just keep going and going and going. They don't run into anything. Like the storm in the Pacific hit the West Coast and stop, or the Atlantic hit Europe and stop. The stuff that goes around in the Antarctic Ocean just keeps going and going and going until the sun sets. The sun robs of the energy, and the storm's going to
It just goes around. It's swirling around.
So we get huge waves, and
It's really choppy. You don't want to sail across that.
it's hard stuff. And then you get to the iceberg fields and get driven in ice.
Real challenge was like those cargo ships.
Yeah, it's really rough. So you're better off flying over that than the interior and landing. It's a fun place. I recommend going.
Okay, I'll be right back.